Alrighty, everybody, we're going to be doing series and parallel circuits. And so the thing about this is there are limitations sometimes to our designs, where series might work better than parallel, or parallel might work better than series. And I'm going to demonstrate that today. Your assignment is going to be to use a 3-volt battery. So we're going to use two AA's, just like this. And the next thing that I like to do is flip my battery. So we're going to flip it around so that the positive is on the left. All right, we're going to start with a simple series circuit. We're going to use one resistor. We're going to hook that up to the positive voltage. We're going to take one LED, flip it so that you can see the flow of the current without having a bunch of wires crossing around. And we'll move that down so it's somewhat level. All right, we're going to go with yellow because it's easier to see. And we're going to connect the cathode to ground, or to the negative. Negative and ground, same thing. All right, when you simulate, yay, you have an LED that lights up. So we're going to stop simulation. This is a series circuit because there's only one path for current to follow. All right, so we're going to make another series circuit. We're going to flip the LED. We're going to drop that LED in. We're going to change the color to yellow so you can see it. Now, if you wanted to connect two in series, they connect so that they flow just like this. What comes out of here is still going to be positive voltage, even though that's the negative connection. It will eventually flow to negative. We're going to connect it to this anode. And now from this cathode, we'll just connect it to negative. We'll line that up like it matters. Then we simulate, and you can see they light up, but not nearly as bright. All right, so let's try 3 and see if we can get 3 to light on 3 volts. Now, when you're doing this, you're going to see the limitation in just a minute. Ooh, let's go with yellow. Let's connect the cathode of that one to the anode of that one. And let's go over here. And I have a surprise for you. Are they going to light? I'll explain why they won't in just a minute. You see, each of these LEDs requires 1.5 volts to light up. So if you add this up, 1.5, 3, 4.5, well, guess what? We only have 3 volts. So if you're limited to a 3-volt power supply, this would not work. I'll prove to you that it will work with 3 batteries. That's 4.5 volts. You could make them brighter if you wanted to knock this down some. Let's go to 330 ohms. So you can see they're still not very bright. Let's change this up a little bit. How about? All right, so let me show you guys. If we're only using 2 batteries and we want these 3 to light up, well, we have to use a special circuit. It's called a parallel circuit. So what I'm going to do is I'm going to orient these parts so that they'll line up nicely. I'm going to move this battery down. You still understand it's a 3-volt battery. And we're going to delete this resistor. And what we're going to do is we're going to rotate each of these so that you can see the parallel circuit. So you rotate it 3 times so the anode, or the positive voltage, points up. Rotate, rotate, rotate. And we're putting that there. And we're going to take 3 resistors and we're just going to snap them right here. That's the easiest thing to do. And you're going to build this circuit. Now we're going to connect each one of these to positive voltage because that is the anode of the LED. Anode requires positive voltage for the LED to work. So you notice I'm taking 3 wires and connecting them to positive voltage. So I'm trying to overlap the wires because really in a circuit you could connect all 3 of those resistors together using a breadboard, which we'll learn later. All right, so now you can see a parallel circuit has 3 paths for voltage to follow. Now the last thing that we're going to do is we are going to connect the cathodes to the negative. So we're going to go down here. I'll line it up as best I can. And we're connecting all of the cathodes to the negative side of the power supply. Now, as ugly as that is, you can see the three paths. So we have one path here, second path here, third path, and they go to ground, or the negative part of the power supply. So when you simulate now, you have three different LEDs that light on 3 volts. Because each one of these paths only require 1.5 volts, it kind of splits it up. So it's almost like having 3 batteries. So this is a parallel circuit because you have parallel lines. It's not always easy to see, especially when you go look at the schematic, which, of course, the way that they put their schematic together is not how I would draw it. It's definitely ugly. But it gets the point across. You can see here's the positive part of the battery, and it flows to resistor 1, resistor 2, and resistor 3. They're all connected right here to the positive side of the battery. On the negative side, you have the cathode of each LED, because these are LEDs. R1, R2, R3, of course, are resistors of 1K value. Cathode of that one's connected, and the cathode of that one is connected to the negative side of the battery through these wires. All right, so that can be confusing. You can look back at that later. And there's other things you can do with this. You could put a switch here. You could put a switch in between to control all 3 LEDs. Or you could put a switch to each LED. Of course, switches are a special case, and we'll go over those in another lesson. This is mainly for you to understand how LEDs are connected to resistors to protect them, because if you don't, they go bang. Like if we were to take this out and just hook this straight up to the power, of course, I don't even think the other LEDs are going to light up because it's a short circuit. Let's just find out for fun. Okay, it explodes. They do light up, probably because that shorts out. That might be the problem. Alrighty, so too much current went to that guy. That's why we use these right here. So I'm receiving a phone call, and I'm going to end your lesson here at 7 minutes and some change. Alrighty, so y'all have a great time working on this.